So this talk, I've given variations of this talk a few times in the last few years. It started off actually as a technology agnostic introduction to machine learning for really targeting C-level. But it's been such a popular talk, I keep updating it. And as I've updated it, it's leaned more and more Microsoft stack because I really think there's some strong tooling in that space. So this talk is going to be very much emphasizing Azure and Microsoft tools and technologies, but a lot of the principles I'll be talking about here could apply far beyond that as well into other stacks. So the last time there we go. The last time I gave this talk was actually at Ignite, Washington, D.C., like right before the whole COVID thing started. This has been updated since then, but it was a fairly popular talk there, so I hope you guys enjoy it. So a little bit about me. So I've been doing development of some form, bouncing through roles for about 20 years now. I've bounced back and forth between management and technology numerous times, but I can't get away from the tech. It's by far the fun part of what we do. Right now, my role is principal architect at the Octavian Technology Group. I recently got my second Microsoft MVP for AI. And the focus is where I've been focusing the last number of years is deep learning, machine learning, cloud architecture, mixed reality, and Azure. So a whole bunch of stuff, but all of it is kind of starting to circle together. What really pulled me into machine learning is my involvement in the cloud. A couple of years back, I was at Build, and I started noticing that every single talk somehow came back to machine learning. Each of the teams was working on figuring out how does machine learning fit in. And that was the moment I realized, wow, I need to get on board here in a hurry and figure out what's going on in this space. And so dove into it. I guess it's more than 2 years now. Maybe it's more like 4, but it's been coming on strong, and you're starting to see machine learning integrated everywhere. So a little bit about Octavian Technology Group. We're a consulting company that's very much focused on being true consultants and staying away from the contracting. So we come in and we usually like to operate at the C-level and help people move forward strategically, and then help them guide them through implementing those. Please touch base if you'd like to learn more, but I'll leave it at that. So I kind of wanted to start this with some interesting statistics. So I've got 3 numbers for you to start. So first is 75. So according to Gartner, 75% of organizations will use deep neural networks that they've customized to try and address things that they could just address through off-the-shelf technologies. $3.9 trillion will be spent Gartner predicts that business value will be created using machine learning, and it will be worth about $3.9 trillion in 2022. So about a year and a half away, they're predicting that much business value is being created with machine learning. And finally, McKinsey & Company states that as of last year, 23% of enterprises have machine learning embedded in at least one company function. So just kind of a reality check to get you an idea of where machine learning is fitting into what we do. It's coming on fast and coming on very strong. So today, what I'm going to do is we're doing the intro right now. We're going to talk a little bit about my definition of machine learning. It's still a little bit fuzzy what each person means by machine learning. So I like to kind of set a baseline for the talk. Then we'll dig into tooling and standards, take a little bit of a look at integration and deployment, take a look at versioning, talk about biases and other risks, and then finally get to recommendations. Really, the entire point of this talk is kind of my recommendations based on my experience. So I've been out there as a consultant helping companies roll out machine learnings within their product teams and their development teams. So this is kind of some recommendations based on my experience, and that's really what the entire talk is building up to. So, and just one more point of order. I would encourage anyone to jump in and unmute and ask a question if you have a question. I'd love for this to become a bit of a discussion as well. Otherwise, if you're not comfortable with that, I know we've got time at the end as well. So, machine learning definition. So, when I take a look at Wikipedia, the source of all truth in in our industry. What is machine learning? So they say it's the scientific study of algorithms and statistical models that computer systems use to effectively and yada, yada, yada. I just put the first paragraph, but they go on and on about it and kind of explain a definition of machine learning. So, and it's a very good one, but let's boil it down to what I'm really thinking of when I think of machine learning. First, it's something that uses training data. So we're using some form of training data to make decisions, and we're learning from that. This is machine learning is not something where we've pre-planned and developed an algorithm. This is something where we've actually learned from our training data, and it's using that experience to make decisions. And how does it do that? It looks for patterns and uses inference. So there's not going to be those explicit instructions or algorithms. It's model-based. So what we're doing as we do the training is we're creating a model. And that's kind of the core of our machine learning is we train and create that model, then we use that model to make predictions and do inference. And finally, there was a joke going around a year or two ago that machine learning is just glorified statistics. And I want to really emphasize the idea it's not. When I take a look at what we have today as machine learning, what I really see is computer science and statistics coming together. So we're bringing in concepts like biases, weights, models, regressions, but that doesn't make this a segment of statistics. ML is a segment of computer science based on statistical learning theory. And this is the moment where I find out if there's any data scientists, because they would be shaking their fist at me for that comment. But my point is that it's really bringing data science and computer science together, and that brings us machine learning. So hopefully that helps you guys kind of get a picture for what I'm thinking of as I talk about machine learning today. So let's talk about tooling and standards. And as I mentioned at the beginning, we're really going to focus in on the Microsoft stack and Azure here. So first thing, I kind of like to start at the highest level. And the highest level is pre-built services. So within the Microsoft stack, we have the Azure Cognitive Services. So these are services that somebody in Redmond, or I should say a team in Redmond, has spent a bunch of time training and kind of solving some generic off-the-shelf problems. And these things have had a lot of investment put into them. They're kind of ready to go. They're easy to apply. Currently, there's 27 different services available, and I think there's a few more that are in public preview right now. But they're constantly growing. They solve a lot of very common problems. And they're very easy to work with. The last time I applied one of these to a problem for a client, it was within one working day, I had kind of that prototype of how this is going to work because I had a working machine learning model to start with. So it's a really good way to kind of get going quick and dip your toes into machine learning. Kind of the next step down from there is Azure ML Studio. At least I think it's still called that. It's kind of, the name has been a moving target for a while now, but it's a part of the Azure machine learning suite, and it allows you to do some machine learning with drag and drop modules that you can connect together. So these are kind of no coding services, and there's competing products to this one, but this is what we have in the Microsoft stack. I have used this for projects successfully. It's really nice tooling, but in general, my personal feelings about this is it really targets data scientists, data engineers, and people that really aren't doing a lot of code typically. And as a developer or somebody whose roots are in development, I found myself a little bit uncomfortable here. In this space, I would rather just write code than use this tool. But it's a great tool that's out there for people that aren't necessarily as code focused and maybe have a big math background. So they're well equipped to do machine learning, but not necessarily coding. And the end result of what you get out of this is you publish a Rust service that you're able to use to consume and make predictions based on the model that you build out in this tool. So take another step down, and this is a fairly new offering, is AutoML. And if you do a Google search for AutoML, you will find that there are about 6 different products from different companies called AutoML. Microsoft has one that's part of the Azure Machine Learning Suite, as well as part of ML.net. And what's really interesting about AutoML is the best way I can describe it is it's machine learning that is used to create your machine learning. So basically what ends up happening is you give it kind of a problem space, here's your data set, and it does a lot of the work of both setting up your machine learning as well as iterating and trying to find what the best model is. And so the machine learning that Microsoft has developed is actually machine learning to help figure out what adjustments to make to a model to try to improve it. So when this works, it works really, really well. I've recently used it for a production project, and it was quite amazing to get a custom model built for me that was highly accurate. And it was another example of something where I sat down, and the very first day I was working with it, I had a working prototype. Now that one I had to spend a little bit more time to get up to production ready, but it nonetheless made it much easier. And really the goal with this service is to democratize machine learning. And that's something that if you've seen a bunch of Microsoft keynotes in the last number of years with Satya, it's something that he emphasizes is the importance of democratizing machine learning and getting it out of the ivory tower of data scientists and computer scientists that have focused in this space, but bringing it to every developer and making it accessible, and also making it accessible to companies that don't have $1 million budgets to do these projects. So it's kind of been a really exciting offering. And to be honest with you, when it first came out, I thought it was a little bit dubious. And the initial versions were kind of so-so. But as it's matured and they've added features, what it does really, really well. So it's a place that I'll often start, is just try AutoML. And if it doesn't work, I'll move on to other methods. But it's a good place to start because it gets you there very quickly. So kind of going the next level down is now looking at some of the higher level libraries. And so these are libraries. The ones I'm focusing on here are libraries for building your own neural networks. So we have ML.net, which actually does decision trees as well, and Keras. And both of these are higher level libraries. So these libraries actually have these different types of machine learning models already built. And what you're doing is just customizing them to your need. So think of this like using a framework that somebody's already pre-built for you. and they've kind of implemented all of the different bits of computer science, like using the .NET framework. You don't go and build your own hash table anymore like I used to do when I started. Instead, you just use one of the many built-in, very refined ones in the .NET Core SDK these days. And these are kind of the same types of libraries, but aimed at machine learning. So as a developer, I found myself very, very comfortable in these. The only catch for those of us that have been Microsoft most of our careers is these are Python based, and I should say Keras is Python based, and ML.NET is C# based. But the majority of these types of libraries are all Python based. ML.NET is kind of the new player in this space, trying to bring this into C# world, which I think is amazing, and I can't wait for that to mature a little bit more. But what we're really doing is allowing developers to do their machine learning with code and abstracting away the complexity of machine learning itself. So the gotchas here is you really have to understand the machine learning and what you're doing. This isn't like AutoML where you can let the machine learning figure out your machine learning. But the nice part is you're not actually implementing these algorithms on your own. You're using some nice off-the-shelf implementations. And finally, going kind of to the lowest level here, we have my examples are TensorFlow and PyTorch. And something you'll take note of here is that neither of those are Microsoft products. And for a while, Microsoft had the Cognitive Toolkit, which is actually the way I got my MVP originally, was by doing a lot of work in the space of the Cognitive Toolkit, and then they basically announced its cancellation a week later. But the general recommendation is to use TensorFlow. If you're working in everything else Microsoft stack, it's a very mature and very, very popular library. The second, but kind of a distant second, is PyTorch. And those are the two that you typically hear people talking about. They're both Python based, and most of the other competing ones are. So these really target the machine learning engineers. So this is for somebody that needs to implement some of their own algorithms. So you're doing some custom work. So you're going to, if you're needing to get to this level, you're probably working with a data scientist, or you're trying to follow a paper that came out of academia or something like that. So the other thing to take note of is these typically integrate with NVIDIA CUDA. And that's where they get a lot of their processing power and their learning capabilities. And NVIDIA kind of dominates this space for GPU acceleration. There have been a couple of attempts by AMD and Intel, but so far it's completely dominated by NVIDIA and their offerings. And in fact, if you go and spin up some compute to do this in Azure, you're going to find that the GPUs are professional series NVIDIA cards that you're working against. So, and finally, I want to just bring up standards. So there have been kind of two competing standards for a little while now. We have ONNX in the neural network exchange format. This battle is pretty much over. ONNX won by a long shot at this point. Any framework that is reasonably popular will have import and export to ONNX. So what's really cool about having those capabilities is I can build something out, in Python with TensorFlow and with Keras on my machine, generate an ONNX model, and then I can load that up with some of the machine learning capabilities that are now built into .NET Core and load that exact same model. Or I could load it on a Raspberry Pi, for example, using totally different frameworks. So it's basically a way of exchanging models between these different frameworks after they're built. So it's something that I always like to highlight is when you start thinking about building your own models, I highly encourage you to start thinking about focusing on these standards, and it'll give you a lot more flexibility in the long run. So next is integration and deployment. So, once I've got my machine learning, so what do I do with it basically? So I always tell people to think about it as when you're building your machine learning, think about it as you're building machine learning as a service. So you want to provide something that is simple and easily consumed. So almost every time I find myself building some custom ML, I typically will build it as a RESTful service because most everyone is comfortable with that. And it doesn't even matter what platform they're consuming it on. It's easy to work with and easy to integrate with. And when you take a look at the output of the various tooling in Azure, they're all going to do something very similar. When you do an automatic deploy, they'll provide you with a RESTful service. And the key element is you don't want the developers that are going to consume this to have to really understand the inner workings of the machine learning. Instead, you want them to understand here's the interface of what I need to provide, and here's what's going to come out the other end, just like any other RESTful service. So based on that, I highly recommend encapsulating it. Make sure that you create appropriate boundaries and really stay focused on the idea that you're going to want to independently release this uh, completely independent of the rest of your system. And I'll talk a little bit about why that is later. And finally, in some cases, you find that you can't completely isolate the code. In that case, take a look at logical boundaries. For example, using containers is a great way to provide that isolation, and something that's been provided on IoT Edge. So it's a great way to get that isolation, but on a platform where you can't just encapsulate it into a different machine or something like that. And so I wanted to talk about the tooling. So this is an interesting slide. When I first made this slide, it was a scattering of tools. And now it's kind of all coming together. And this is through the efforts of Microsoft that this story kind of is starting to pull together and be a lot more consistent. So if you're an infrastructure as a service person, you've got Azure Machine Learning for training. You can deploy with Azure Data Science VMs. And for your pipeline, you can use Azure ML Ops. If your platform is a service, you can use Azure Machine Learning for training and deployment. And for your pipeline, you can use Azure ML Ops. And finally, if you're more focused on containers, Azure Machine Learning, Azure Container Service, and Azure ML Ops. So the very first time I did this slide, it was 9 different things were on here, and it took a lot of explanation to go through. This time it's kind of all centered around Azure Machine Learning. And that's because really Azure Machine Learning attempts to be kind of the one-stop solution and a very holistic solution from start to finish for doing your machine learning, regardless of kind of where you are on your cloud journey, whether you're still IaaS or PaaS or containers or even functions as a service. So this is a good juncture to do a little bit of a demo. So I just talked about the wonders of Azure Machine Learning. So let's slide it over into a demo of Azure Machine Learning. So what we are seeing here, let me actually go to the front page. So this is what you get, and now mind you, I've got a bunch of stuff actually deployed here, but this is what it looks like when you dive into Azure Machine Learning Studio, and you'll notice that we've got a whole bunch of tooling on the side. So it looks a little bit like a typical Azure service. And actually, let me zoom in a little bit here. It looks a little bit like a typical Azure service, but it's not. It's really a collection of services kind of in one place. And you'll notice that it's even got a separate portal, ml.azure.com versus the typical portal.azure.com. But anyway, this kind of becomes your one-stop shop for doing your machine learning. So one of the first things I guess to point out is we can connect up data stores here. So I've got a few different data stores set up in here, and a data store can be, you'll see I've got blob storage and file shares in use in these examples, but it could be Cosmos, it could be many different sources. But the idea here is that it understands where this data is, and what I can do with that data now is I can make a data set out of it. And making a data set, now I've got versioning going on. You'll notice this particular data set, I've got 8 different versions that I've created. And so what's really nice about this is as I register these data sets, the different versions of the data sets can have can consume some of the same data. So I don't have to have literally 8 different copies of this data set. In some cases, it's just the difference plus the old data set. So and if I go into this data set, there's nice tooling that lets me explore the data set. So I can take a look through what the data actually looks like. There's information on how to consume it. You can see they give me some sample code. It's just a nice way to help manage your data as you're working on this stuff. But ultimately what you're doing is you're creating experiments. So the concept of an experiment is I'm going to do an experiment that represents some machine learning, and then I'm going to do these runs and iterate over it. So for this particular model, I've done 359 different runs. So that's 359 different iterations on the model, trying to improve it. And now you're thinking, wow, that's really high. And the reason it's high is because it's AutoML. So using AutoML, I'm actually able to rapidly do, oftentimes I'll get 60, 70, 100 runs out of just one execution. So I just want to highlight kind of some of what comes out of AutoML here. Actually, let me pick a good one here. So if I take a look at this particular run, I can see all the different child runs. So when I do AutoML, I mentioned that it's basically machine learning that's figuring out how to do my machine learning for me. So each of these runs it's doing, it's taking a look at the results, and based on the results, it's making some adjustment to how it's doing the model, and then rerunning it again, and it does it over and over and over again. And here I've got access to all of that. And I can see that in this case, what my best algorithm was, what my accuracy was, and I can dive into this and take a look at some of the metrics, get some charts pre-generated for me that helps me understand what happened with my model, which is really handy because somebody that's used to doing machine learning can take one glance at this and see that there's a problem right here and right here with the way that I fit my data into my model. And something new that they're adding is the concept of explanations. So this is still in preview, but the idea is that you'd be able to get some information about, well, why did my model work the way that it did? Oftentimes it can be a little bit of a black box. So the explanations is a way of starting to open that up and tell a little bit of the story of what occurred there. Other things to point out is a compute cluster. So I have multiple different compute clusters here. So this one in particular is my GPU cluster. So this is the one that's kind of the big the big compute power for doing my trainings. And you'll notice that it's currently has 0 nodes, and that's done intentionally. So when I set these things up with Azure Machine Learning, at least when I'm paying for it, I'll set it up to have a minimum number of nodes of 0. And what that means is at the point that you actually submit work to it, it's going to spin up a machine, it's going to do the execution, and then it's going to spin down right away, minimizing your costs. So this particular VM that I'm using is about $600 a month. So by doing that, I can get that down to, $50 a month instead, when it's only running at the moments that I need it. The penalty for that is that I have to wait for it to spin up every time. So it adds about 10 minutes to each run. But when you're doing runs that are 3, 6, 8 hours long, that 10 minutes isn't really that important typically. So the one other thing that I want to highlight in here is the model that comes out of this. So at the end of this, I get an actual model, a machine learning model, and I have the opportunity to then deploy that as an endpoint. So right here, I've got an actual endpoint from a model I've trained, and it's presented as a RESTful endpoint. So I can actually go to this URL and consume it and make predictions based off of that. So kind of that entire the entire story is managed for me, and that's what I really get out of Azure Machine Learning. And the reason I said earlier that I feel like they are Microsoft is kind of ahead of everyone else here. It's not because any particular piece of tooling is light years ahead. It's because they have a holistic story that helps you get from start to finish. And oftentimes when I do development, that's more important to me than having the best of breed. I'd rather have all my tools well integrated and just plain work together. And that's what you're getting in this situation. And on top of that, they've been working really hard at integrating what they're calling Azure ML Ops. So think of this as a combination of Azure Machine Learning and Azure DevOps. So now I can bring that CI/CD pipeline and flow that you're typically used to. I can bring that into my Azure or my machine learning development. So again, it's adding kind of all the missing pieces, and all of that stuff fits nicely together. So you can get to a point where you've fully automated this, where you do a check-in and it does a training, it does a validation, and if everything's good, it automatically deploys your model into development, which is just like how I like to develop software typically. So it kind of brings you a lot of the things that we've learned and developed over the last couple of decades in the development world, and brings those into the machine learning world as well. So normally I wouldn't spend a lot of time on versioning, but for machine learning, versioning tends to be a very, very difficult problem. So I wanted to talk a little bit about that, just to give you kind of a feel for the situation in this space. So kind of where I like to start this is talking about how you actually design your machine learning. Make sure you're designing for replacement. Plan on your team iterating a lot, and I mean a lot, especially in the beginning. Plan a versioning strategy that allows you to swap out daily if you need to. And typically you will find, especially as your very first versions come out, that you will need to sometimes switch models on a daily basis. So whatever you do, don't tightly couple your ML service to your training. So make sure that you can insert a new version of the training without having to redeploy the ML service every single time. And I tend to think of it as this is a moment where I want to really think about A/B testing the same way I would if I was doing a UX project. So I just like to assume that I'm going to do that, and it's because I know that ML models. I've seen this many times. You get an ML model, it works just brilliantly in tests. The whole team pats itself on the back. And then you deploy to production and it falls apart. And it falls apart because of an edge case, or it falls apart because the data had something wrong with it, or there's many different reasons, but it's not unexpected. So have a good way of of doing some testing. And so by creating an A/B mechanism, now when I do a new release of my ML, maybe I'll set it up so that 5% of the users get that new version, and then take a look at how it's performing and what's happening, and then crank that up as I see that, oh, this is working well. Let's have 50% of the user base use it. And this gives you two things. It prevents you from just totally bringing down your system if your ML doesn't work as expected in production, but it also gives you a fallback plan. So if I do get to that point where 5% are using the new version and it's failing horribly, well, I just switch that to 0% and figure out what went wrong instead of panicking and trying to do a new release. Really, these are kind of lessons from other parts of development as well, but they're especially important in the machine learning space. So what are the different elements that you need to version? When we're doing typical development, we version our source control and we're good. And that is the very first thing that you have to worry about. So we have code and we follow standard source control procedures. Get Azure DevOps wherever you happen to live currently. That's where you want this to live as well. But now we have data. So because we're actually training, basically that code is going to load data and use it to execute a training. So the data is as much a part of your source code as the code itself. So if I want to be able to reproduce a training, I need to have the version of source code and the version of data. So that's why it's really important what I showed earlier, that they have the concept of different versions of data sets within Azure Machine Learning. So before that showed up in there, I had like 3 or 4 slides explaining all sorts of different angles that you could use to version data, and they all kind of stunk. So this is an area where they really made a huge advancement for all of us. And next is the model. So once we complete a training, Azure ML will automatically pickle your model. So pickling is just the Python tool that does serialization. So it'll pickle that model and give you a nice binary file that you can then unpickle to deserialize your model and be able to use it again. So typically you would want to do version control on the model and also on the training. So the training is the weights that are applied to the model once you've actually done it. So with Azure ML, it does that automatically for you. It creates the versions and it puts them out there. So again, it's kind of doing a lot of the work for you, which is really, really huge in this space. And finally, think about interface compatibility. So standardize your inputs and outputs to the model. Consider model interface changes to be breaking changes. And those breaking changes will require versioning your service. So there's kind of this hidden layer of interface that you have. You have the interface to interact with the model, and you have the interface of the RESTful service itself. So either one of those changing is going to result in you having to version your service. So what are some of the risks that you have to deal with when you're doing machine learning? Well, the first one to talk about is bias. So bias can cause an algorithm to miss the relationships between the features and the targeted outputs. I've got a sample of this that I'm going to go to in a second here. So that's typically referred to as underfitting. Variance is kind of the other end of this, and that's where your training will actually hone in on the noise in the training data. So looking at this picture, if I use this picture as part of my training, if I had overfitting or a high level of variance, it would actually train on the noise in this picture and say that that's a train instead of training on the actual train itself. So that's referred to as overfitting. So kind of putting this into graph form, here's kind of some examples. Imagine the blue points are your points of training data. And the red line represents a function that is the model that you're getting out of this. So if we have high variance and we overfit, we get what we have on the far left, where the model is very, very tightly tied to the training data. So the net result of this is you're going to get fantastic results if you do a prediction with the training data, but once you start bringing new data in, it's going to miss really bad the model. So this is one of the places where you can have a model fail horribly in production if you've overfit your model when you're doing training and testing in pre-production. So high bias is kind of the other end of this. That's where you get a model and it kind of is just in the middle. It's not really focused on any particular part of the data. So you're really underfitting that curve to the data itself. And that means that your model might do okay, but this is the type of model where you get in the real world and you find that your accuracy is something like 50% because you're essentially flipping a coin and half the time it'll get right and half the time it won't. So what you want is a good balance, and that's the one on the far right here, where we fit the data, but we're not overfitting the data. So if we start to get some points, some new points in there, it should fit relatively well into our training. So this is a really important thing to watch out for. And the reason I talk about this in this talk is that this is where teams will almost always go wrong in their first time taking on machine learning. They'll get either high variance or high bias. They won't recognize it until they get into production, and then their model fails horribly. And there's some great ways that you can figure out if this is going to happen. And there's some great graphs inside of Azure ML that actually give you a good view of that if you understand how to interpret them. So, and that's maybe a little bit of subtext that I never directly say here, is it's really helpful to get some help from somebody that's got some experience in ML that can do some mentoring for the rest of your team, if at all possible. And finally, data is really messy in the real world. Whenever I give a talk and I give an example, I show this beautiful set of data that works perfectly, just like every other example or demo you've seen in a talk. And it never works out that way in the real world. In the real world, we have too little data, and we need to figure out a way to either capture data or generate additional data. We have missing data points, right? Not every single data point is even there in a data set. And ultimately, it's a lot of work. This is really the hardest part of machine learning, is getting the right data set together. So it's a matter of collecting the data, figuring out, do I even have the data to do this type of machine learning? I've had a couple situations where I've had to tell people, okay, this project just turned into a project to figure out how to capture the data you need. And then we'll have to come back to this in like 3 months or 6 months once you've got a data set that we can actually work with. It's never the answer that people want, but you need a good set of data to do this training. And you need the data to be properly shaped. And yeah, I tend to find that when I do a machine learning project, I'll spend 60 or 70% of my time will be in getting the data right, getting the data shape right, and getting it ready for the training process. So something to have in the back of your mind is kind of an area you might not think of as being as big of a deal as it is to machine learning. So finally, my recommendations, kind of where this is all building towards. So my biggest recommendation is start small, work smart, save money. Think about what are the low hanging fruit that we can chase, and what are the ones that we can do where we can use some off the shelf machine learning. So I always encourage people select a problem that can fit into some of the off the shelf solutions like cognitive services so that you can get get a win under your belt, which can show your leadership team that, oh, this machine learning stuff actually works. And our team is capable of working with it. And oh, it saved us this money, or it increased our revenue, or whatever the benefit is that you're going to. Getting that quick win is really helpful, and there's often these low hanging fruit. Whenever I take on, so typically for us when we take on a new client that's interested in machine learning, it rarely starts with I've got this ML problem, go solve it. It usually starts with something like the CFO was reading a magazine and they said that everybody should be doing machine learning now. Um, how do we do machine learning? It's usually something more along those lines. So what we'll typically do is help people figure out, here's a dozen, and this is what I would recommend you do too, inside your own company. Figure out with stakeholders, what's a dozen different things that seem like they could be done with machine learning, and then figure out, how would we actually solve these problems? Figure out which ones are the easy ones, the quick implements, the quick wins, and figure out what the benefits are, and kind of weigh that all together to make sure that you get you chase some of the easy ones first. I've had numerous clients where they have this big, huge vision of what they want to do with machine learning. And I will sit there and listen to it and think that is amazing. If you do that, you're going to dominate your industry. But then we start to talk about it and realize, oh, well, this is going to take a dozen data scientists and 50 machine learning engineers to hammer out. That isn't where you want to start. That's almost a guaranteed failure. And this is just like any other development, right? You don't start at the end. You find some incremental steps to get you there. So that's kind of where I recommend starting. Then as you move forward, take a look for pre-built neural networks. So a lot of these neural networks will be built and they'll be available as open source. You can find them out on GitHub where they're solving additional problems beyond the scope of cognitive services. So typically with these, you're going to do a little bit of customization, but for the most part, you're just using an open source neural network. So these are really great to get your team, for your team to get used to the language change if they're not normally a Python team, get used to the tool chain and figuring out how to kind of use all this stuff without having to learn the nitty gritty details of building this stuff on your own. So it kind of lets you dip your toes in. So that's a great second step if you can find some off the shelf open source neural network that you can use. Then third, I suggest do a proof of concept with a higher level library. So this would be like a Keras or an ML.NET. So this is picking something that's very specific to your domain. So there's nothing off the shelf. Using these high level libraries to build your own machine learning, and but to do it in a proof of concept form. So you really want to fail fast. And a lot of teams will get stuck in this. We have to build this out production worthy. No, just build out the bare minimum to show that this is going to work. Then focus in on the steps you need to get there. And again, this is just like the advice I would give on projects outside of the machine learning space too. And then finally, Chase, doing these full solutions. So I've got a good POC under my belt. How do I develop that into a full production system? How do I scale that out, especially if it's something that's consumer facing? How do I make this something that can handle the maybe thousands and thousands of predictions that are needed every hour? um, and my advice is to stick with the high level libraries, stick with the CARES, stick with ML.NET, and avoid going down into the really low level stuff unless there's a specific need that forces you to. So you'll know it if you need to go and start implementing from scratch, but don't do it unless you really have to. A great anecdote I have, this was a few years ago. A startup came to me and said, "Well, we've been working with this consultant over in Australia, and she's been building out this machine learning that's based on this academic paper that was done by one of the founders of the startup." And they were like, "Well, she's been working on this for months, and it barely does anything." And I took a look, and what she had done is she started building it in TensorFlow from scratch, and she had custom implemented all the little bits and pieces. And what I saw is 30 or 40,000 lines of code for what could have been done in Keras in about 100 or 150 lines of code. And it's kind of a cautionary tale. It's really easy to get pulled into the I want to implement this all myself. This is really cool stuff. But in reality, just like anything else, use the high level libraries when you can and only resort to completely custom implementations when you need to. So that's kind of my advice of the spectrum of how you start small and build up to something. And hopefully, as you're doing this, you're not only getting your team experience with working with these tools and technologies, but you're getting those wins under your belt that are getting your leadership and your company. They're building confidence in the work that you're doing with machine learning. And based off of that, that's where you're going to get your funding and get your extra team members and what you need to really do some of the big picture projects. So the next question that always comes up is data scientists. We must hire some. And I always urge people, don't start by hiring a data scientist. And I say this as a consulting company that has data scientists. Part of what we do is actually have consultants as data scientists. And don't do it though. So don't start there. And the reason is, everything I just told you to do, that's going to be really frustrating for a data scientist. They're going to want to jump all the way to the end of building a very custom stuff. They're not even going to want to look at the off-the-shelf stuff. They're going to become frustrated. So start small. And as you build up, you'll know the moment where you need to bring a data scientist in, whether it's as a consultant or a permanent staff member. But do not start there. I've seen a couple companies that started there, and the data scientist will build out all this really cool stuff, and they'll be able to give a great demo. But a data scientist isn't going to get that into production. You typically need a machine learning engineer, and then usually the two have to collaborate quite a bit to get something that can actually go into production. It's really easy to build out a machine learning model that works really well, but is so computationally or memory expensive that it's cost prohibitive to actually bring into production. And those are things that a data scientist isn't going to think about. So you really want to do some of the easier stuff first, and then figure out if you even need a data scientist at all. So as you start looking at some of the pre-built stuff that I just talked about, this is a recommendation of me. Take a look at the facade design pattern. So I think it might be a Gang of Four design pattern, but if you Google for it, you'll be able to find it. And I use that to make sure that you're decoupled from whatever pre-built service you're using. Those pre-built services could go away. you could find out that, and I hate to even say this here, but you could find out that the IBM version of that service is far superior, and you want to switch to it, whatever it happens to be. Make sure you're decoupled, and that's just me putting my architect hat on. I would give you that advice for many things that you use off the shelf. And then have a high level library strategy. So figure out what high level library you want to use and pick something that's really popular. There's all these really wonderful ones out there that are really cool that have some neat features, but they have like 1/100% of the market share. You're much better off to go with something like Kara's where they have, you know, 20, 30, 40, 50% of the market share. I don't even know what they have, but it's super popular. And like anything else out there in our development space, if it's really popular, when I run into a problem, I'm going to be able to Google and find lots of answers. So I recommend picking something that's a really popular library. And it's also something that's got great development behind it. Um, and then look at using Azure machine learning. You know, I kind of already honed in on this for everyone, but Azure machine learning is a big shortcut to numerous problems that you have to solve when you're in this space. So use that to deploy as a service. And then plug that service into your current architecture and current infrastructure. Do not try and turn the whole team to whatever tooling that you used for this. Just because you've built this as a RESTful service, they should be able to just plug it in. And then be flexible. So I talked a lot about Onyx earlier, but use an open standard in a format like that so that it gives you the flexibility to deploy in various places and to move your model from framework to framework if needed. And for training, so one of the things that people love to do is to run out and buy a whole bunch of GPUs and servers. We're going to do this machine learning. We got to have all this compute power right here. So I'm here to tell you, do not do that. Instead, leverage the cloud to train. What I usually recommend is instead get some small GPUs, enough that you can run your models locally, but not do a full training. So you can verify that they're going to work before you push them to the cloud, but then do that big training in the cloud and have the hours worth of a machine tied up be a cloud machine. And also, don't own those really expensive GPUs yourself. So use Azure machine learning and data science VMs to accomplish that. And come up with an upfront versioning strategy. I talked a lot about how you're going to find yourself deploying a model, finding problems, redeploying, and you might find yourself doing it daily on your first releases. So a good versioning strategy is really important to get that up front. I highly recommend deploying to containers, which is something that's pre-baked into Azure Machine Learning at this point. So deploy to a container, that way you can keep multiple containers around and switch them out as needed. Plan for A/B testing, I talked a bunch about that earlier, and have the ability to instantly roll forward or roll backward. So if a deployment goes really poorly, you're ready to roll forward or backward as applicable. Don't hesitate to try AutoML. AutoML is a little bit of a controversial thing in this space right now. A lot of the real machine learning people don't think that AutoML is the way to go. AutoML is really great though when it does work. And it's worth giving a try. And I tell people, don't let perfect be the enemy of good. I hate to use such a cliche, but it's really the case in something like this. So if I can get a model out in one day instead of 4 weeks, is the slight lack of accuracy or whatever's different between the two worth it? More often than not, it'll be you'd rather do it quickly and move on. But it all depends on your domain. are you building a model that's going to be used for medical diagnosis, or are you building one for marketing? How perfect that model needs to be is drastically different in those use cases. So bear that in mind as you're looking at applying machine learning and auto ML. And finally, data version control. So this again was a slide that used to, I would talk about how tough of a problem this is to solve. And here's a whole bunch of tools you can try. I don't even bother with that anymore. Just use Azure ML. And remember that your data is much, much closer to being like what you think of as code in your development projects here, and treat it accordingly. Um, Understand how to effectively use the data sets and data storage that comes baked into Azure ML. So I'm going to skip that. And now coming back to where we started here. So 75% of organizations are going to build their custom neural networks where they could have just addressed these problems through off-the-shelf ML techniques. Now, hopefully that has a little bit more resonance for you after going through this. Gartner's predicting the business value of AI being 3.9 trillion. So make sure that your company is getting that business value by you should really be doing figuring out where machine learning fits right now. And then 23% of companies are already there using machine learning in one of their company functions. So just some stats to leave you with that we kind of started with to really kind of make you think about, well, why aren't we doing machine learning yet? And hopefully I gave you some good ideas of how you can get started. So here's my personal contact info, my blog, my Twitter, and my LinkedIn. So feel free to reach out to me afterwards with any questions, but I'd love to take some questions right now if anyone has any.
There any particularly interesting ML problems that you've solved or seen solved for clients that you're able to share?
Um, sure. I think if I avoid saying who the client is, this is probably generic enough. Actually, I've got a couple that come to mind, but one that is very recent for me is a particular customer had a volume of emails coming in on a daily basis, requesting basically quotes for their products, and they're pulling in about 600 of these emails a day because they're fairly popular at a national scale for their particular type of product, and their products are very custom. So what they would get with these quotes is they would get an email saying, okay, we'd like you to make a quote. Bids are due by this date, and that sort of thing. And then they would have to make a decision as is this something we spend time creating a bid for? And if yes, they would have to go do the bid. So because of the volume they had, well, I should say they have, because of the volume they had 13 people whose sole job was to open these emails, read them, and decide whether or not they would bid, not even create the bids. So then they would pass them along to the people that would create the bids. And it turned out when you dug into kind of the stats of this thing, they're typically only bidding about 20% of the volume that comes in. And the reason for that is because they had some of them were coming in too late. They needed 5 days lead time to actually generate a bid. So if it came in less than 5 days, they would discard it immediately. If oftentimes the same request would come into multiple people within their company, and then those people would all forward them to the queue. So they would get the same request 10 times over. So they'd have to manually filter through that. And when you're dealing with the scope of hundreds of emails that multiple people are touching, that's actually a pretty big problem because I may not have seen the previous version of that email. And even if I did, I may not remember it because that may have been 100 emails ago. So they kind of hit all these problems, and then even beyond that, doing the quoting, they'd get to a point where they'd have to look at blueprints and read through the plans, and all of this stuff was required. So they were spending a ton of money on a yearly basis just quoting work. So the machine learning that we built, it did a few things. It went through and figured out, well, what is the date that this bid is due, and figured out if they were duplicates. So that was version one. And just figuring that out was able to eliminate about 40% of that volume right off the bat. So it basically eliminated about 4 people's jobs just by doing that. And then moving forward, it was there were a whole bunch of other problems to solve, like figuring out who the contractor was that was requesting the bid so that they could connect that up properly within their CRM system, which again would save time because they had to manually do that. Going through what sometimes were 100-page documents and figuring out, well, are these even products that we make? Because oftentimes they would just be in a list that contractors would have, and they would pump out the request to bid for 100 different vendors, and it might not even be applicable to them. So we did a lot of text analysis is essentially what it was, but what was cool about it is it enabled us to eliminate these people's jobs. And they didn't actually eliminate their jobs, though. They took them from doing really boring stuff, which is reading emails, and making very simple decisions that anyone could do, and allowed them to place them into more skilled positions where they could do things that were of a higher value to the company. So in the end, it turned out to be a win for those people because they got to do more interesting work, and it saved a ton of money on the front end for the company. So that's one example that was really cool, although not very flashy, but worked out well and saved a ton of money. The second one goes back a number of years, but basically I had a client come to us and say, and this is a company that made equipment for buildings, and they said, well, we want to be we want to be the building. We want to be like Jarvis and Iron Man was the actual request. It was like, we want our product to be able to do that. And so we started working on a prototype for them, and we ended up doing some really cool stuff. We used a lot of the off-the-shelf Azure Cognitive services. So they wanted it to be a truly interactive, feel like we're interacting with Jarvis experience. So it had to do speech recognition. It had to do speech generation. What was really interesting is we got to do custom speech recognition, which is a service called Chris within Cognitive Services. So we were able to train it about stuff that was within their product domain. So words that you would have never even heard of before. So an off-the-shelf speech model would not be able to understand. Well, with Chris, we were able to actually extend an off-the-shelf speech model to understand these domain words. But then we used that, and we hooked in bot framework to create a conversational way of interacting, as well as using Lewis, which is another of the off-the-shelf cognitive services, which was actually understanding what the user was saying, what was their intent, and what were they trying to act on with that intent. So with all of that, we put together a really awesome technology demo. Unfortunately, that one didn't make it much further than that, but that was more internal company politics versus success of the demo. But it was really neat having the mission of trying to reproduce Jarvis. So those are a couple interesting examples.
Cool, thanks. I mean, it's that email one. I mean, I actually like to hear ones like that because usually, they are the moonshot type projects you hear about, not the like, here's a practical problem that can get solved.
Yeah, definitely. And that was definitely one of them. And that, just not to keep going too long here, but that was one of the customers where they came to us with this grand and big vision, and we kind of helped them hone in on, I think we got to about 8 different ideas that were really solid that we could demonstrate the business value. but this particular one had the highest business value for the lowest implementation cost. So that's how we ended up chasing it first. And they're still iterating on this, but this is being used to justify them to the CEO that, hey, we should go invest in one of these other machine learning projects where we can get this benefit for this cost. Because now we kind of built up that trust of, oh, you actually did do this, and it really did save me that money. So as a consultant, that's what I always strive for, being able to actually demonstrate my value. Any other questions?
So I guess that's no other question. Am I muted?
No.
Oh, we hear you.
We hear you.
We can hear you.
Okay, yeah. So I guess if there aren't any other questions, I guess we'll go ahead and wrap up the presentation portion and move. I'll go ahead and stop the recording.